So, having the knowledge of Y-intercept as well as the X-intercept for the actually equation of a straight line, let's now think of applying the concept in actually the following case. How should we be able to determine the area of a right-angled triangle bounded by the intercepts of the graph of a straight line? For instance, let's say we have this as the equation of a line. Let's say we have y is equal to, let's say, 2x, let's say a minus 4. So what is the equation, or what is the graph of this actually equation? It's now a simple and straightforward. We just have to come up with the x as well as the y-intercepts of the graph, rather of the equation. So let's start with the x-intercept. X-intercept, so that is x-intercept, or have it upon having y is equal to 0. So now which means we'll have it as 0 is equal to 2x minus 4. That will give us x being given as 2. Therefore, have the point being given as 0 should be 4, 0. Of course, this is the x-intercept. So, but the point is given as this. And how about the y-intercept? So, on the y-intercept, we'll have it as when having x is equal to 0. So now, which means we'll have y is equal to 2 times 0 and then minus 4, of which y will be given as the negative 4. As a point to have it as 0, negative 4. So these are the intercepts of the equation of a straight line. So now let's think of having the straight line connecting the 2 points. So now the best way to actually sketch the graph of the straight line is just have to identify the intercepts. That's the best method to go for. So you have to know that that's the best way to go for whenever you are to plot the equations, the graphs of the straight line. So the best way is just have to identify what is the intercept. And instead of going over on the table value and some stuffs, of course we already discussed about all this, but this is also the best way to go for, as you can see. Now let's think of having the graph here, and we have it in this case. That's the Cartesian plane, and I'll have y, and this is the x. So we have the x-intercept, that is 4, 0. Let's say this is the point. Now I should have it as a 4, 0. That is the point, of course. Let me just have to have it this way. That is 4. And what is the y-intercept? We have it as, so have it as, should be, this is negative. Let's say this is the negative 4. And of course, in real sense, we have this as the 4, 0, and we have this as negative 4, should be 0, negative 4. That is in real sense. So now, let's think of extracting the right-angled triangle bounded by these intercepts. So now, first thing, connect the 2 intercepts. So have it as this. That is, then we'll have it as this case. So we'll have it in this case now, like this. So now what we have is right-angled triangle, of which this is the 90 degrees. So how should we be able to have the area of this triangle bounded by the intercepts? So now area is given as the half base times height. That's the area of the right-angled triangle. So how should you have the area in that nature? So now all we need is what is the distance of this side and also this side as well. So in that case we'll have, what is that? We have here as a 4, should be 4, and this is the zero, of which the distance will be given as 4. And how about here, also have it as a 4 as well. Mind you, the distance is given in actually as a positive, so have negative 4 minus 0, that will be given as the negative 4. Now what is the absolute value of the negative 4? We'll have it as a positive. So generally the distance is given in is given as the positive. So now which means we'll have the area being given as half. What is the base? We have it as a 4. And what is the height? We also have it as a 4. So which means the area will be given as 2 into 2. 24 is given as 2. So have it as 8 units square. So that is the area of that triangle formed, bounded by the intercepts of the graph. So take note of that. And what if we have this case? Let's say we have the equation given as, let's say, should be now this case, let's say 2x minus 2y, let's say it is equal to negative 12x. So it should be this. So what is the area of a right-angled triangle bounded by the actual intercepts of this actually equation? So now let's first of all express this equation to be in the general form. In this case we'll have it as negative 2y is equal to actually positive x, the minus 2x, and the minus 12. And that will have it as negative 2y is equal to negative x, and that should be minus 12. So now have y being given as now x over 2 and minus 6 should be positive 6 upon dividing everything by negative 2. Now we have this as the actually equation of the line in that order. Now the principle remains the same. We'll have to calculate what is the actual intercepts. What are the intercepts of the line? And that can be given as, in this case, we'll start with the x-intercept. So upon having y being given as 0, so now have it as 0 is equal to x over 2 and the plus 6. Now have to multiply everything by 2, have it as 0 is equal to x plus 12, of which x will be given as the negative 12. So the point will have it as negative 12, comma 0. Now this is the x-intercept, but as for the point, we'll have it as that. And what if we have, let's say, we should have to go for the x-intercept, should be y-intercept, where x is given as 0. So now have y is equal to, should be a positive 6. So that's the actually x should be y-intercept, where now as a point we'll have it as positive 6 should be positive 0, comma 6. So that is the point. Now let's think of having actually that particular, it should be a graph representing the information that we have, and we should have to see. So mind you, we have the x-intercept, and are given as should be, what is that? I've forgotten G. So it is given as the negative 12. So x-intercept is given as the negative 12. The y-intercept is given as, and that should be, now y-intercept is given as a positive 6. So take note of that. Now I have to come up with a graph presenting the information that we have. And say we should have it in this case. So we should have, what is the x-intercept? We'll have, let's say this is the negative 12. Of course, the y-intercept is given as, let's say this is, should be a 6. And I'll have to connect the 2 points with the straight line like this. And I come up with the line of the triangle, we'll have it as this. So that is, so now which means we'll have, what is this distance? We have it as 6. and that this is 12. Now in that way you'll be able to have the area of that triangle. So take note of that.